Thanks for coming, and thanks for expressing an interest in learning more about engineering education research in ECE. I have a really unusual position in the College of Engineering, and I'm at a place where I'm trying to recruit some students to work with me in my research lab. And there's an opportunity for students to get engaged in some other activities beyond my own research. So I just wanted to kind of have an opportunity to share with you some of the exciting things happening in the space of engineering education research and to hear what you have to say about it. So as I said, I have a really unusual career path. I do have a bachelor's, a master's, and a PhD in electrical engineering from here. So I have 3 degrees, so I'm a Wolverine 3 times over. And I currently am an associate professor in EECS, and I have a courtesy appointment in the School of Education, and I'm director of our engineering education research program here in the college. And for those of you who might be familiar with the Center for Research on Learning and Teaching and Engineering, I established that office 14 years ago and ran that office as director for 10 years before taking this faculty position. So let me start by telling you about the field of engineering education research, especially as it pertains to ECE. So engineering education research is a interdisciplinary field which is recognized internationally. Basically, it's a space which is a rigorous scientific discipline where methods that are used for educational research and social science are applied to study issues that are relevant to engineering education. Things like teaching and learning, college access and persistence, developing a solid and diverse workforce, and other things that might be pertinent to the field of engineering. So I often describe engineering education research to folks by using this spectrum, which describes a range of different ways to get involved in engineering education research. So effective teaching is what many faculty and instructors strive to do, which basically involves using good content and effective teaching methods in the classroom. But as faculty and instructors get more informed about what they're doing, they often apply principles of scholarly teaching, where they read and reflect on the research and try to apply research-based practices into their teaching. Scholarship of teaching and learning goes one step further, and it allows instructors to investigate what's happening in the classroom in terms of student learning. So it's fairly classroom focused, and it allows you to assess how things that you're doing are making a difference in terms of student learning. And then as things get more and more rigorous, we move into the space of engineering education research. So this is a field that extends beyond the classroom, and it extends beyond just thinking about student learning and really starts to answer questions about why and how things happen. So my own research portfolio, I feel like I missed a slide. My own research portfolio addresses issues related to student learning and faculty teaching practices and the relationship between those. I study things that really involve bridging the gap between the research about effective teaching and the research about effective learning. So really trying to bridge the research to practice gap and have some of the evidence-based practices applied in real life. So some of the questions that I ask in my research are things like, how do engineering students learn and grow and develop? What can we do to foster better student development and to measure that as well? What can faculty do to help make students be more successful? What can we do as instructors or as a university to promote and increase diversity in engineering? What can we do to promote more widespread use of effective teaching? And how does the design of the classroom affect learning and teaching? So let me just tell you about a few sample projects that I've been involved in to give you a better flavor of the work that I'm doing. What I wanted to tell you was that there is a range of different kinds of activities that people study in terms of engineering education research. And the reason it was missing is because this slide can't be printed out as a single slide, so I didn't include it in that handout. But the questions that people ask range from things about pre-college activities, like how and when do young people start discovering engineering, and how are the engineering and science standards being implemented in math and science classes in K-12, There are also a lot of questions related to the engineering pipeline, like how do admissions policies contribute to the underrepresentation of specific groups? Or what can we do to foster the success of a diverse student body? Most of the research that people are familiar with in this field centers on the undergraduate experience, like what are the most successful flipped classroom designs to really support student self-directed learning? What can we do to measure students' motivation or self-efficacy? What impact does a particular teaching practice have on student success and learning? And what students do outside of the classroom, how do those activities affect their engineering identity? Graduate students are also an obvious population of study in engineering education research. And some of the research questions ask things like, what is a successful set of practices for mentoring graduate students? We also ask questions in the field, like how do practitioners really develop a deep expertise about what they're doing? And then broader issues that span things beyond education, like what underlies successful change initiatives in higher education, and what kind of policy issues in STEM might have the greatest impact on engineering education. So in terms of my own background, I told you that I have a PhD from Michigan. After I left here, I went to Kettering University, which is a primarily undergraduate institution, and I was on the faculty as a tenure track and then tenured electrical engineering faculty member for 14 years. And I approached my teaching in a really traditional lecture-based way. You know, I taught the material, I lectured to the students, they took notes, they seemed to do fine on the exams, and so things seemed to be going just fine. But then I got exposed to some different kinds of teaching. I went to a week-long teaching workshop. I really got to collaborate with people, think about teaching outside the classroom, look at what some of the research-based best practices might be. And then I started using more student-centered teaching in what I was doing. And I was using active learning practices, and it was a lot more fun. The students were learning more. I could push them deeper to learn more complex material, and everybody seemed to be more energized. So this active learning was something that was really exciting to me, and I wanted to study more about what I was doing. So I started engaging in the scholarship of teaching and learning. I started attending workshops on educational research, started reading education journals, going to conferences, pouring through textbooks about engineering education, and really trying to learn the space of engineering education research. And then I moved my work into the field of engineering education research. So I transitioned from a traditional disciplinary-based electrical engineering faculty member through a series of steps to somebody that focuses primarily on engineering education research. During that same process, I got involved in faculty professional development. And in the past 15 years, I've established 2 different centers for teaching and learning. At Kettering University, I started the Center for Excellence on Teaching and Learning. And then at Michigan, I founded the Center for Research on Learning and Teaching and Engineering. So I started getting involved in faculty development. I left my faculty position, came to Michigan to run the CRLT in engineering, and then through a series of really exciting initiatives in the college. Last year, I took a position as a faculty member in EECS. So now I am a regular tenured associate professor in electrical and computer engineering. The primary difference between my role and everybody else that you see in the department is that my research is on electrical and computer engineering education research. So it's a little bit different research, but I teach circuits and other EE courses. I serve on ECE committees. I sit with all my colleagues and do the regular ECE stuff. So I told you that my research focuses on student learning and faculty teaching, and I asked these kinds of questions. And I had wanted to tell you a little bit about, I think, 4 different projects, just to give you some snippets about the kind of work that I do. So in the space of faculty teaching, I have a particular project which is funded by National Science Foundation, where I was looking to understand what instructional practices are most commonly used in our engineering classes at Michigan. So to study this question, I collected data from a random sample of 26 engineering undergraduate classes at Michigan, and we did structured classroom observations. So I had a team of research assistants who learned how to apply this observation protocol and went into the classroom and took data about what was happening in the classroom. And mainly in those classes we found probably the things that you could guess, that there's a really wide range in the overall teaching style that's used at Michigan. We did find that there's a lot of variation in the kind of questioning and answering that happens among students and faculty. And we also found really limited use of active learning. One of the main takeaway points of this research is that we were able to use the data that we found here to get administrative support for a large faculty development initiative that we ran for the past 5 or 6 years. And we really were able to engage a lot of faculty in that faculty development activity. So this is a faculty learning community really designed to help faculty use more student-centered practices in their teaching. So a second project that I've been engaged with has to do with understanding students' ethical development and learning more about the kinds of things that students do that have a positive impact on their ethical development. So for this project, we did focus groups of students, faculty, and administrators at 18 different institutions across the country. We created a survey that we administered to almost 4,000 students, and we found some interesting things related to students' ethical development. We found that having involvement in co-curricular activities, especially being a leader in co-curricular activities, can really positively influence ethical development. We also found that students that have higher levels of ethical reasoning are less likely to be satisfied with their ethics instruction, meaning maybe we're not pushing the students far enough in the current ethics instruction that they see in their undergraduate experience. And we also found that the level of complexity of the ethics instruction is a lot more influential on their development than the amount of ethics instruction that they have. So as a result of this research, we know that ethics is now taught differently at a lot of different institutions, including the 18 institutions that were involved in our study. Another project looks at students' teamwork skills, and in particular studies the impact of a theater sketch that we helped to create, which can be shown to engineering undergraduate students. We were looking at the impact on students' ability to work effectively on teams. So the sketch was performed in 14 Intro to Engineering courses. It was performed in 9 Engineering 100 courses, and we have data from 5 classes where it was not performed as control data. We have more than 1,000 students that completed a pre-survey and a post-survey in both of those groups. And we found overall that students who saw the sketch were significantly more prepared than those who didn't to address a lot of issues related to teamwork and future issues. So things like lack of communication, lack of having a plan of action in that team, and lack of unity on that team were factors that increased as a result of their ability to address these issues increased as a result of seeing the sketch. And now this sketch is integrated into the Introduction to Engineering course in a pretty major way. Most classes, this is a required course for all first-coming engineering students, most classes have this sketch as part of the class. I'm involved in a study right now where we're looking at why students are resistant to active learning in the classroom. And we want to know what instructors can do to help overcome that resistance. And in this case, we collected a lot of different kinds of data. We did some classroom observations. We did some focus groups with students. And we've conducted faculty interviews and student surveys in over 20 different institutions across the country. So this is also a project funded by NSF, and it's a collaborative project involving faculty from multiple different institutions. We found some interesting things here. We found that students, as you might guess, expect that professors will mostly lecture. And so that sometimes when the instructor doesn't lecture, there can be a little bit of resistance from the student's perspective. But we found that the confrontational kind of verbal resistance that faculty might expect to happen really happens rarely. And there are some solid things that faculty can do to help introduce active learning to overcome some of those things. So there's a lot that faculty can do to avoid some of this resistance, and it's pretty low stakes things that are straightforward and easy to do, like explaining why you're doing it and walking around the class while you're doing it. We also found that in-class group work is really valued. by students, but underutilized by faculty. So that's another place that faculty might take advantage of active learning. Right now, we are still in the process of analyzing the data that we've collected, but we are integrating some of these findings into workshops about active learning, both at Michigan, at some of these other institutions, and then for national workshops as well. So some of the future research directions that I have planned involve a project which will be submitted to NSF, looking at what we can do to revolutionize the curriculum to really leverage diversity at the undergraduate level and better prepare tomorrow's engineers. So this is a project that could potentially be funded down the line. We're looking at what teaching practices really have the greatest impact on supporting a diverse student body in ECE, both at the undergraduate and the graduate level. I think we have an issue that the department would like to overcome in terms of lacking diversity at both the undergraduate and the graduate level, and that's a concern that the faculty have across the board. So we'd like to look at faculty learning communities, which was a way that I have been connecting with faculty across the college, but we're looking at what we can do specifically in ECE courses in terms of creating a faculty learning community to help influence the teaching practices there. I'm interested in knowing more about a flipped teaching approach and what we can do in undergraduate ECE courses to make that successful. And I also have a project that I'm in the middle of defining, which really is looking at how a flexible classroom design, one like this where the tables can be configured in one particular way, or you could arrange them in rows like a lecture style, or you could have them in small pods so that faculty could work together in groups, looking at what the influence of that flexibility is on both faculty teaching and student learning. So that's sort of a quick overview of some of the opportunities and the research that I'm doing. But I wanted to tell you a little bit more about some of the educational opportunities that you might be interested in. If you do want to learn more about the field of engineering education research, there are a variety of reading groups and workshops that are periodically offered for the College of Engineering. I have a listserv that I maintain for graduate students and faculty that are interested in learning more. So why don't we pass that sign-in sheet around, and if you would like to be added to the listserv, just put a little note next to your name and I'll do that as well. There are courses that you can take to learn more about engineering education. Every year there's a teaching engineering course which is offered in the fall. So that's an interesting place to learn more. But there are also a lot of courses in education, psychology, statistics, and so on, where you can really learn more about the methods that you might apply to engineering education. There also is a Rackham certificate in engineering education research that any engineering PhD student can add to the courses that they're taking. It requires 9 hours of coursework and an engineering education research project. One of those courses is the teaching engineering course. It also requires 2 courses on research methods. One of them is a quantitative research methods course where you study more about how to analyze the numbers that come from some of the research projects. And one is a qualitative research methods course where you learn more about how to analyze mostly the verbal data, the things that are not necessarily numerically quantified. So those 3 courses, and in addition, a research project. So students that complete the certificate program will have this noted on their diploma that they completed the engineering education research certificate. There are also opportunities to get involved in some of the research projects that I described to you. Many of the projects are NSF funded projects. So there are some limited funds available to support students on some of these projects. And then I kind of wanted to just lay out, for those of you who might be interested in doing something in the lines of engineering education research, kind of the spectrum of ways that you might get involved. So starting on the left, if you're not really interested in doing this formally in terms of your degree, you could just attend reading groups and read materials and get involved in some of the community activities and get your standard ECE degree like you are already planning. But a couple of other things that you could do. You could add the certificate to your ECE degree, and this, as I said, would allow you to have this noted on your diploma. Another option is to pursue your ECE degree, but have an EER-focused dissertation. So this would require you to move through the ECE curriculum, pass the qualifying exam by meeting the regular requirements, and then working either with me or your advisor or two of us together to think about how you might tailor your research in the ECE space around engineering education research. But fourth, we don't have this yet, but we're in the process of proposing an EER, an Engineering Education Research PhD program. This will probably be available for students to start taking classes in as early as next fall, but it wouldn't officially be on the books for students to apply to until the fall of 2018. But one of the requirements of this PhD program is that it will you'll need to have a master's degree in an engineering discipline. So you could potentially continue the way that you're going now, get a master's degree in electrical and computer engineering, and if this was something you were totally interested in, you could then apply for the EER PhD program and go that route. And then on the far extreme is not even getting an ECE degree or an engineering degree, but applying for the School of Education and getting a PhD in education. So that's really what I wanted to cover for you. I wanted just to kind of give you a flavor of the field and just describe some of the different ways that you could get involved more. But mostly I wanted to have an opportunity to answer any questions you have and share other things that you might be interested in.